Okay, I'm just going to go over a couple more examples that you might see similar ones in your homework. So I'm just going to go over a couple of these. So looking at number 11, we're going to expand this. So we're going to use the quotient property. And so this will break this up into log base 4 of 64 minus log base 4 of y. So now that it's broken up, looking at the first part of it right there, this is basically asking you 4 to what power would give you 64, and that would be a 3. Now, 4 to what power would give you y? Well, we don't know what y is, so we just have to go ahead and leave it like that. And there we go. That's that one for you. Okay, let's try a couple more. Okay, over here we'll try 27. Okay, so there's a couple things going on here. You have a product and a quotient. So it doesn't really matter which one you break up first. It's probably going to be better to do the quotient first, but really you could break up the product first if you really wanted to. But okay, so here we go. We're going to go log base b. And we're going to have x squared y, and then this will be a minus because of the quotient rule, log base b of z to the second power. Now what we'll do is we'll break up the product that's going on here. So this will be log base b of x squared, then we'll have a plus log base b of y, and then minus log base b of z squared. Okay, and the last thing we're going to do is the power rule. We're going to take those powers and we can put them in front as a product. So our final result would be 2 times log base b of x plus log base b of y minus, and then that 2 goes in front, log base b of z. And that's what we're looking at. Okay. You can put a time symbol, or you could just put 2 and then write the word log. That's fine. It's the same thing. So when you're doing your homework, when you type it in, you don't have to put the multiplication symbol. You can just put 2, and then from your toolbar, put the log and put your base in and all that kind of stuff. Okay, let's try 31 now. Okay, so what I want you to notice here is this. Oh, that cube root is applying to the whole thing, to the x and the y. Okay, so what we'll do here is we'll go ahead and rewrite that as an exponent. So it's going to be log of x over y raised to the 1/3 power. So that's the same thing as taking the cube root. Now that 1/3 is applying to both of these. Okay, so you can go two different ways with this. You can go ahead and distribute that power to both the x and the y, or you could move it to the front. Okay, I'm going to move it to the front, but you do have to be a little careful here, okay? Because now I have to do my quotient rule and break that apart. And what's going to happen is that 1/3 needs to belong to both parts when I break it, okay? So let's go ahead and do that. So I have my 1/3, and then I'm going to break this into log of x minus log of y. And let's see, my base is just understood as 10, so I don't have to list it. Okay, uh, now when we expand these, you want them to go as long as possible. So what we're going to do is we're going to distribute that 1/3, and that will cause the expression to be stretched out even longer, right? So now I have 1/3 log of x minus 1/3 log of y. And there you go. That's your answer. Um, you could have gotten the same answer, like I said back up here, if you would have distributed the 1/3 to both the x and the y and then did the quotient rule and then moved the 1/3 to the front. It would have worked the same way. It would have been the same result. Okay, looking at 33. 33 is actually pretty similar to one we already did. So I'm going to I'll go ahead and skip that one. Let's look at 35. So 35, once again, so see I have that cube root right there. So I'm going to have log base 5 of x squared y over 25 raised to the 1/3 power. Now, once again, you could go ahead and distribute that 1/3 power everywhere, okay? And that's fine. I'm not against that. Or you can move it to the front and distribute it at the end. That's what I prefer to do. But if you wanted to, you know, um, use your power rule now, you can do that if you want. But this is the way I'm going to approach it. So 1/3, I'm going to put this in brackets. I'm going to have log of 5, base 5 of x squared y over 25. So the brackets aren't necessary yet, but they will be necessary in my next step. Okay, so that's why I just go ahead and put them in now. So then we're going to have 1/3. And then when I break up the quotient, I'm going to go ahead and just do this all at once to save myself a little time. I'm going to break the quotient and the product. So this is going to become log base 5 of x squared. And that's going to be plus, when I break up the multiplication right here, it's going to be log base 5 of y. And then because of the division here, that will be a minus log base 5 of 25. Okay, so hopefully, you know, you can do that in 2 steps if you would prefer. I just went ahead and did it all at once. It all kind of depends on how comfortable you are with that. Okay, so then if you look at this, I can move, oops, I can move the 2 to the front right here, just in front of the log. Okay, and I can evaluate this right here because this is saying 5 to what power gives me 25. And that's going to turn into a 2. So I still have my 1/3 on the outside. And then this is going to become 2 times the log base 5 of x plus log base 5 of y. And then this will become a minus 2 right there. That's what this simplified into right there. Okay, so the last thing we want to do is distribute that 1/3 to all 3 of these right here, okay? So 1/3 times 2 would become 2/3, and then you have your log base 5 of x. And then here, the 1/3, there's an understood 1 in front, so that'll become plus 1/3 log base 5 of y. And then 1/3 times another 2, it's going to be minus 2, so this will become minus 2/3. And there you go. Okay, I think I might have a few more. Let's see. All right, let's see if I got one down here. Okay, 57, that one's not too bad, but we'll go ahead and take a look at that. So we have 3 times the natural log of x minus 1/3 times the natural log of y. So what we're going to do is we're doing the opposite now. We're going to take something that's been expanded and we're going to condense it. And in our last section, 4.4, you'll begin to see how this stuff can be useful. So this kind of stuff's going to help us solve problems in our last section of this unit. Okay, so we'll go ahead and move that power back up here, and then we're going to move the 1/3 back up here. Okay, just leave the minus where it's at, and then the 1/3 is actually the same thing as a cube root. So we're going to go ahead and write it like that. So minus the natural log of the cube root of y. And then the last thing we'll do here is bring this together using the quotient rule. So we're using all the same rules, just in the opposite order. We're condensing it. So let's see, we'll have x to the 3rd on top, and we'll have the cube root of y on bottom. Okay, and that's it. That's all we're looking for on that one. Okay, to my last page, let's see what I have marked here. Okay, I think I only have one for us to look at, 65. Okay, so it looks pretty challenging, but um, it's not that bad. You just got to break it into smaller pieces, okay? So the first thing I would do is kind of like, PIMDOS. Let's take care of order of operations. Let's go ahead and do what's in the parentheses here first. So we're going to go ahead and add that together, which we're going to use the product rule. So that'll become 1/2 times log base 5 of x times y, right? And then over here I have x plus 1. Don't let that throw you off. That's just x plus 1. We can't really do anything with that. Sometimes that throws students off. They think, oh, I can multiply or do something, but that's just going to stay as is right now. So we're going to leave that the way it is. Okay, so then next would be exponents. And so we can move these exponents back where they go. Okay, so we'll go ahead and do that. So we're going to have log base 5 of xy raised to the 1/2 power, and then minus log base 5 of x plus 1 raised to the power of 2. Okay, then we're going to convert the our fractional exponent back to radical form. So this, the xy to the 1/2, we're actually going to write that as the square root of xy. And then we got minus log base 5 of x plus 1 squared. And the last thing we're going to do here, oops, last thing we're going to do is bring this together with the quotient rule. So let's see, we're going to have log base 5 of the square root of x and y, make sure they're both underneath the square root, and then divided by x plus 1 squared. And that is our final result from that. So kind of like I was saying, right now you're kind of getting practice for our last unit, because in our last unit we used the properties of expanding and condensing to help us solve equations. So we haven't gotten to the equation part yet. Hope these examples help you.